Progress.
Okay. Share the screen. All right, so we're going to take a look at what we have. So it's a reminder again, exam 1 is Tuesday, guys. So exam 1 is on Tuesday. Don't miss exam, right? It's 10% of your grade, I think, right? So there'll be 10 questions. You have to come to class, close notes, and you can bring your cheat sheet. Can't use electronic, internet, chat GPT, anything. Not yet. All right. So so today it's the last, it's kind of like the end of 1/3 of the class where we kind of wrap up. We're going to move on to still cryptography, but just another set of algorithms that are slightly different. So and then we'll keep using block ciphers, just not writing the code for them, like the algorithms, right? Instead, we're going to use libraries, etc. Because we're going to continue our journey to build SSL itself, and we are going to need all these things to create one final protocol that we can use to encrypt securely. So today, this week, the module has been the data encryption standard. So hopefully you understand how that works. Nothing fancy there, just blocks, XOR, and then some logic, right? Moving things, shifting things around, moving blocks around, I would say. Remember, AES is supposed to be more secure. It's a more advanced algorithm, still based on the same principles, but we're not going to cover it in class as another algorithm. So, but it's simple, okay? Just definitely more secure. The last thing we're going to do today in the sequence, we're going to go back to our Python XOR code. So before we did the hashing algorithm. That was a simpler implementation. And today we're just going to use kind of the same idea, but just a little bit more complex, right? And instead of doing hashing, you should understand which was a one-way thing, right? From variable length blocks, you could argue, or variable length messages, breaking it into blocks and producing a fixed length, block or vector. Now, with encryption, with what we're going to do today, we're going to look at encrypting and decrypting CBC, the CBC mode of operation. So similar idea, but we need to encrypt and decrypt. So we need to create those two functions. The good thing about this is I'm just going to be reusing some of the code that I've already implemented. So I'll basically look for the XOR code and copy that basically. Okay, so that's the plan. And then we'll finish out this part of the semester. I also finished grading one of your assignments, the first one, I think, so check your grades. That usually gives you feedback of how you're submitting your materials and everything, if it was okay or not, right? So check, ask questions, and I'll keep grading as we move forward. All right, so yeah, and then the exam on Tuesday. So now let's take a look at, as you can see, I provided the crypto code here. So you can basically follow along. I'll just explain it, and then you'll have to encrypt and decrypt something. Is that a file? I guess I put a file in there, right? So you can download it then. I thought it was a link. It's not a link. Oh, yeah, it is a link. Yeah, that's what I thought. Okay, great. So the code should be there, and let's read the problem. Basically, I'm pretty sure it says to build a CBC. Yeah, so let's take a look. All right, so this is our last script for the third of the semester. Complete the following problem as done in class. Use the instructor provided XOR code to implement a scheme, in this case, CBC, right? And I showed you the diagram on Tuesday that allows you to encrypt and decrypt some data using symmetric encryption techniques. The key aspect is that you should generate several blocks from the input, and you should encrypt with CBC. Implement the Python code and show your results with screenshots and comments. You need to run it without errors and show evidence that it works, right? So that's the basic idea. To understand the algorithm well, because on the exam, I could change and say, implement ECB or implement OFB or, something like that. All right, so that's basics. Yeah. You need to do this with a partner and the same thing as usual. You need to do this with a partner and send the encrypted message to your partner to decrypt. Reading and writing to and from files may be required for this problem. It just depends on, if you want to risk, because you're going to get a bin file, right? So what are you going to do with that? Are you going to just copy paste that via email? Is that a wise decision? We've covered how to do this already, right? In one of the labs. Remember that if you just copy paste things that are binary, put them in another format like Word, email, sometimes it changes to just one character. From a single quote gets changed or something, and it's not going to decrypt as you know. And then you'll submit a report of your results. Make sense? All right, so let's take a look at this example. So I'm going to start the virtual machine. CBC XOR 2. Okay. Okay, here we are. So let's log in. I'll just start from the main as usual, start with a message. We're going to start going through the functions and just encrypting it and decrypting it. Okay, so open up the terminal. Into the desktop. Go to ITS 350. Okay. All right. I have done the XOR hash. Oh, that's probably sure. All right, so this let's just take a look at it. It's just to kind of use something that you've already studied, right? That you already have a sense of how it works. Let me use nano. All right. So this was the function. We did my gen key. We did the padding. get blocks, hash function. Okay. So I'll just reuse this or copy it. I'm going to do CP XOR hash function, and then I'm going to create, I'm going to give it the name of the document, CBC. CBC XOR, I'm just going to call it XOR 3. Okay, just a little, it's somewhat similar to what we had. Okay, so I copied the file, ls-l, there we are. They're exact copy, 1703 in size. So now we can work on this one. I'm going to do nano CBC tab. Great. All right, so this is where we're doing our work. So remember, this is now encryption. So some things will be similar, but or different, but I'll try to keep some, as much as I can similar to what we did before. So let's start with the main that usually, illustrate, motivates everything that we're doing. So I'm going to have a message. Okay. Actually, let's just do it properly. So I'm going to read it from a file, just like we did in that example. Go over here, and I'm going to say F in, F in open, right? We did an exercise, a separate exercise, which is this open. And we're going to say we need a file name here. So plain dot txt. Let's do underscore. Plain underscore text underscore CBC dot txt. Okay, this is just a text file with your secret message. Okay, and then it should be fine. So now let's read it. Let's read it. Space there. My message. Okay. F underscore in dot read. We'll read the whole. Okay. So this will make things easier, and going forward, I'm going to try to be more consistent with this, because you definitely need to send this file, the encrypted file from here to your classmate. So now I'm going to do, so this will have certain things, right? Certain issues. So I'm actually going to show you by first creating the message. So similar, my message. Okay. And then I'm going to put here an input. Just got to comment out everything. Okay. So I added the 3 single quotes before and after the code to actually comment it out. All right. So Control X, Y. Now I'm going to go here and I'm going to create the file. So I'm going to do nano plain underscore text CBC dot txt. That looks right. Okay. Hit enter. Okay, so the message, this is a very secret message, and the secret code is, and I'm going to do something like that to complicate things. I'm going to say 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, sure.
Can you go back to your Python?
Yeah. So I'm going to close this one, Control X, Y, Enter. Scroll all the way down. So all I've done is that. The file doesn't exceed, so if you exist, so if you run it right now, it's going to give you an error. That's what I'm doing right now. Did you find it?
I'm running it, right? Oh.
Well, don't run it. How about don't run it? Because I haven't.
Oh, you didn't.
Yeah, I have not done it yet. So just wait for me. Right now, if you notice, I commented out everything, and the function shouldn't be an issue. If you got those to work before, right? If you followed the video. Yes. Oh yeah, it's okay. So if to comment out, if you don't want to add the pound sign to every single line, you can use 3 single quotes. There's single quotes. So it's 3 single quotes to open and 3 single quotes to close. And that way it comments out a whole block. Question? Yeah. All right. So yeah, so don't run it yet. But basically, I think it should run. So Control X, Y, okay, nothing to save. Again, the plain text CBC is what the secret message. So I was writing that 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 9, 8, 7, 6, 5, 4, 3, 2, 1. QW RET RUT TIYP. And then I'm going to hit another enter here. I'm just going to add random GDG FS V XV. All right, and I'm going to hit one more time, enter. That's our message for some reason. This is our secret. It really doesn't matter. Like I just wrote, this is a very secret message, and the secret is, and whoops. Okay, a bit bigger. Is this better? You guys see better about this? A little bit bigger. All right, so hopefully you can see. All right, so everyone got this, right? So it's just a message, whatever you want it to be, but put some code in there. Secret code. All right, so now let's run our code. It should work. It should be this one. Let's just do Python. You can do Python 3. Okay, it works, right? All right, so we have some things in there, special characters, right? So if you notice, it's nicely formatted. There's a new line character. I would recommend get rid of that. Okay, get rid of these new line characters for now. Later on, if you're making more robust code or whatever, it could work, but for now. So that's what I'm going to do, just to avoid any errors. There's enters here. And even though you can't see them, and that's called a new line character. All right, so I'm going to get rid of them. All right, so I'm going to go back. Nano, the .py file. Not running, but yeah. All right, here we are. So we know it runs. That's great. So now I'm just going to do some cleaning of the file. So I'm going to do my message of the data I've read from the file. And we're going to say that my message is equal to my message, but it's going to have a replace in there. Replace. And what we're going to say is we're going to replace the new line character, which is denoted by \n, and we're just going to replace it with nothing, right? So that just cleans up the message a little bit. Okay. So we can keep going. We can run this one and you'll see the effect. You see now it's just one single line of message, but the spaces are preserved, etc. Okay, and definitely leave the spaces in. All right, so now let's go back to the code. Now the block size, I think that's something we had defined already in the previous code. So we set length of 8. Okay, so this, I'm gonna use this, but I'm gonna change the name to be len of block. Here, I'm gonna say len of block, and we're gonna, still keep it at 8 just to keep things simple. So now we're gonna use a function we had already created, the block to create the block list. So hopefully this one still works. So let's take a look. So I'm gonna do block list. Here I'm using an uppercase L just because you don't have to. So then I'm gonna call break message. That break message. So we're gonna give it, of course, my message, comma, and length of 1. This function hopefully should be very similar to the one we had created. Everyone with me? So we're just doing that. So let's take a look. So break message function. Yeah. And before for us, we called it get blocks, basically. So I'm just going to rename it to break message. Break message. Like that. All right. So the parameters this function takes are the message itself and the length of block. That's the same as here, right? So plain and length, so that has not changed. The scope of these variables is just within the function, so you can name them with something new. Takes in a list of blocks, that's correct. Okay, and then find range and message and block. A little bit different. And this also, the one that I have also does the padding. So I'm just gonna do that, the one that I provided in the link. Should be similar, but you'll get to see about it. This one is a lot simpler, actually. That one is a little bit more robust, but I think it's more appropriate. So let's go with that one. Right, so also to keep it consistent here, I'm going to rename this message. That's how I start introducing error information. Message length of block. Okay, so list the blocks. Okay, that's consistent. Then we're going to do, we have from message, so I'm going to do for I in range. Okay, just like that. Colon, don't forget. This is going to be a the range from 0 to len of message, whatever it is, probably like 30 something, right? And we can add a third parameter to this range, that is the step size, right? You've used this before, so step size of 2 for every even or something like that, or uneven. And in this case, the step size is going to be length of block, 8. Okay. Okay, so now we're just going to slice out the block from the message by using these parameters. I'm going to do 1, 2, 3, 4. I'm going to say block, and I'm going to take message, and I'm going to slice from I, colon, So that means that imagine it's like a range of values, like a list, and the colon just indicates range. So it's from I to I plus something, right? So in this case, I plus len of block. I plus len of block. So if I look at this, it'll start at 0, right? And it'll grab from 0 to 8. Next iteration, it'll grab 9, and it'll grab 9 plus 8, whatever that is, or 8 plus 8, because actually it starts at 0. Right? So actually it starts at 0. So it'll go like that from 0 to 7, 8 to, what is it, 15, right? And so we can print it if you'd like. I mean, there's no reason why not do that. I'm going to do print I, and also, and then we can remove that. Print I plus len of, so it should be, okay, so that should run. Control X, Y. Okay, so 0 to 8, 8 to 16, 16 to 24, 24 to 32, 32 to 40. Do you guys see that? And that's what we are slicing out. And that gives us effectively the blocks. Okay, I'll remove that. That was just me, just debugging basically on the fly. And we are recording, aren't we? Yeah. Okay, so now that we have that, we are going to append our blocks. Now remember there, this if statement is because the last block will need padding. So in this case, I think I had done this in 2 functions, but here I'll just do it in 1. So if, I'm going to open wide parentheses there, and I'm going to say if len of block equal len of block, wait, I have this is wrong, right? Parentheses should be there, and then there's only 1 parentheses, like that. Everyone with me? Okay, so if this condition is met, what do? We have a list of blocks, right? 1, 2, 3, 4, and we just add the block to list of blocks. So in this case, list of blocks dot append. This is similar to something we had done before, and we just add block in there. Got it? So that's basically it. Pretty easy. However, the last one will need padding. So in this case, then I'll do else. 1, 2, 3, 4. And similar idea. I'm going to take len of block here, which is 8, minus length of block, which in the last one could be 3 or whatever. So 8 minus 3 would be 5. So now that I have that, I'm just going to do 4i in range C colon 1, 2, 3, 4, and we just pad. And I'm just going to pad with white space, right? So I'm going to do block plus space. There. So that's padded now. And once that it's padded, I can just proceed to make sure it's aligned perfectly with the for loop there, the key. So I'm going to do list of blocks. dot append. And what do we append? We append this block. Just like that. Okay. So now that that's done, go ahead and return it. So this should be, 1, 2, 3, 4 directly aligned with the for loop. Return list of blocks. All right, so hopefully that'll work. So let's go ahead and run the code. And actually, we need to probably tell it to print it. I'm going to go down here. Block list. Print. Block. Uppercase. List. Control Y. Okay, so we're reading from a file now. And there we go, right? Yeah. So we read the message first. And this is a very secret message. And the secret code is all of that. And that should be broken up into blocks. Any questions, guys? Anyone stuck? Remember, the code is provided in the link. You can just reference from there. Any questions? Making sense? Okay, I'm not seeing any questions. All right, so let's keep going. So we have our messages now. And the first thing we probably want to do is we're going to encrypt the message, right? And then we're going to decrypt it. So remember, there's going to be these two functions, pretty much the whole semester, encrypt and decrypt for everything we're doing. So let's go ahead and add encryption. So now here is it's different because we had not created these functions in the previous example. We only did this one-way hash function, right? So for the previous code. So now I'm going to go ahead and add a brand new function here. Okay, and we already know how to use the XOR operation. Remember, if you've forgotten, that's your XOR right there. Okay, but we're doing pretty much the same thing. So I'm going to call it cipher list because it's technically a list. That's the way as I'm writing it. Then I have to format it a little bit. So I'm going to call the function encrypt message. Right, so I'm going to call the function encrypt message. Okay. And we're going to think about what the parameters should be. So you guys know we're implementing CBC. So this is actually literally where CBC starts to appear. Now the algorithm does not need to have, you don't need to have one function with everything, right? It can be one function calling several other functions if that makes it easier to understand. So, but we're definitely implementing CBC. So obviously we need to provide the block list. List, okay. That was actually spelled like that, comma. Just for reference, we're going to have the length of block in there. Length of block in case there's any operations that we need to worry about. Okay. Length of block. And then what else does it need? If you're encrypting with CBC, what else do you need? You have the message. What else? Cipher block chaining. You have an exam in less than 7 days. So what are the parameters? Key, right? The key and the initialization vector. We already created a function that can generate those for us. Key, comma, and the IV. Okay, and as I think I had mentioned that these two parameters, basically we can use the same function. They're effectively the same thing, a random sequence of characters. It's just that you should definitely keep one secret. So this one, right, the key. This still, as you do this problem with your classmate, you need to send that key. You can't achieve perfect security because the key is still being sent, unencrypted. So we have no way of doing that. That's what we'll start covering at the second third of the class after the exam. But so we know that these are the parameters. So let's just finish the notation. It's good form to just add the colon here and then add 1, 2, 3, 4 at the return. Returns nothing. All right, so the function is defined. Now we can, then we'll update it. So here, we're going to think about creating our key. So you can see that. So I'm going to get rid of this. Let's not do it. Okay. You can see that this, we had created my gen key. I'm going to use the exact same idea. We don't need the padding anymore, probably. Let's leave it. Well, actually, pretty sure we're going to do it. I did the padding in the blocks function. All of this actually. Yeah. Just get rid of it all. I'm still using my gen key. Just going to rename. All right, so probably here be a good place to generate your key and your initialization vector. Okay. We're going to call the function gen key, uppercase K here, so gen key. Okay. Just like that. And this will have one parameter that it needs is the length of block, right? Because we're XORing something of the same size as the block. So we don't have any issues. So len of block, just like that. Okay. And then I'm going to repeat the exercise for the key, which is above actually. I'm going to say gen key, open parentheses, len of block. Okay, there we go. So now those are great. They're defined. We're going to print them out. I'm going to do print key. And I'm going to do print IV. All right. So we need to define gen key or just double check that it matches. So I'm going to go to where I defined gen key for the XOR problem. All right, so let's go all the way up. That's where we had. Now, as far as the libraries, notice we're just using OS urandom, okay, which is for the randomness. We might use pickle or not. We'll see. But I'll introduce it now as there may be some things in the future that we're doing that might be like saving a signature and things like that can be have a lot of structure. And so pickle is a really nice thing for that. But saving as binary files might be enough for this example. But anyway, I've introduced the pickle library, just pickle read, pickle dump, and those basically do what that says. They take whatever's in memory as is, and then just dump it to a file, and then they read it back into the file in the same structure. All right, so let's take a look at the function. So I'm going to change the name to what I'm using now to be consistent with the code example, the script I provided on GitHub. So my gen key takes length. That's perfectly fine. And then we had done, this is exactly the same, return a byte array. And the byte array is basically based on a urandom length. And I think we've looked at the output of both of these. Right. All right, so this will just give us our key and our initialization vector. So at this point, we should be able to print these out. So I'm going to go ahead and run the code again. And then these all keep as they are handy. Now we did this print urandom length just to see what happens. So we've looked at that. All right, so control X, Y, clear. There we go. Probably an indentation issue. It's the new encrypt function here. Oh, what are you? Oh, wait. I was defining, or what was I doing here? Yeah, I think I like did that. So I was trying to create the call to it and also the definition to it. So let's just do the definition. This is def, obviously. So if you see this, if you see me like making these mistakes, just raise your hand. All right, so yeah, so this is def encrypt message, right? So now it's defined properly. So then down here, I think I can copy this. Okay. Nano is not always great at that. Other things is really nice. Oh, there we go. All right, so and we call cipher list. Cipher list equals. Now here, definitely remove colon, because that's for the definition. Get rid of that return. Right, so here we're just making the function call. Block list already has data, IV has data, key has data, and length of block has data. So those parameters will be passed nicely to the function, and then it'll just return nothing for cipher list, right? Which is how we have defined it already here. So this should work. All right, so hopefully Control X, Y, enter, clear. And there we go. So no errors, and it's printing out the key and not formatted as we might want it, right? But this problem we already know how to solve. Leave it here because this is actually the data type, right? So leave it here, as we're going to process it as it is in this form. But I gave you the code a few weeks ago, or maybe last week, to if you want to print it out and look at it in a nicer way, just for display purposes. I had given you these functions, remember? You know, print them in hex and then the formatting and everything. So I'll leave those in the code. Yeah.
I'm still having issues wearing that.
You're having what?
Issues wearing.
You have an issue? Yeah, let me take a look. So let me leave it. Oh, so you've thank you. All right. Anyone else stuck having issues? Okay. All right, perfect. As you can see, the code is not difficult, right? The thing that's going to be tricky is those XOR operations and the reverse of it, which, as you saw with the Feistel network, also, you know, you think you understand it in one direction, but then reversing it just, you know, throws you off. Best thing I can tell you when you do those things, when you have things like that, is just like implement something that you think is correct, get it to run, and start debugging it from there until you find, you know, the right thing. Start like printing something and then so on. So maybe I'll do the same. But yeah. All right, so let's go ahead now. And we know that all of these print. So we are at the place where we can go to the definition of encrypt message. We have our key. We have our gen key. I have tried to make this code as simple as I could. And I think the best way was to just create a whole bunch of functions. So this function will call like two other functions. So I'm breaking up the steps into parts. All right, so let's focus on encrypt message. So if you remember the diagram in encrypt was, so actually I actually have that in Brightspace, right? If we go to this folder in my, I think here I would say, in this PDF, right? If we look at it, nope, maybe not here. Okay. Let's go previous one. just do this. All right, so we had seen these, looking for the CBC one. There's many implementations, as you can see. I don't want to have to rewrite this one thing. There it is, CBC, right? So if you remember CBC, which is, the diagram that we did in class of the menu that this page is showing, had these plain text initialization vector, that's one XOR operation, and that produces something that gets XORed with the key, and that produces something. So 2 XOR operations. Do you guys agree? There's 2 XOR operations there, and so that's what we need to think about. I'm going to create maybe 2 functions. Then the function just XORs, but first the IV and the plain text, the output of that, then with the key to produce the final cipher 1. And then I need to take this output and carry it to the next step and so on. Do you guys see that? So let's just do that in one direction. And then, of course, we need to reverse it. All right, so that was helpful. So let's go back to the virtual machine over here. All right, so we are in the encrypt function here. So, right, let's take a look. We need to iterate through the text, right? So that makes sense. So I'm going to do for I in range. And I'm going to have block list, right? Block list is what contains my blocks. So it's a list. I can use length here as well, just to know how many blocks I have. So I'm going to do block, uppercase L, list. So that should be correct, I think. All right, so then remember it's a for loop, so I'm going to do colon, 1, 2, 3, 4. And now 1, 2, 3, 4. All right, so as I said, I'm gonna just break this up into 2 functions to keep it a little bit simpler to understand, I think. So I'm gonna create, one output, cipher 1. Yeah. And cipher 1 is going to do encrypt 1. Let me spell that correctly. Encrypt 1. Okay, and this will be that very first step that I just showed you. The block, the plain text block, and the IV, the initialization vector. Okay, so then parameter. So we need to pass the block. So block list. Do you see that? So I'm using the index to grab the blocks. I know there's maybe 17 blocks. So I grab block 0, block 1, block 2. And I am going to XOR it with the IV. We don't even have to worry about what's going on in here. I mean, we will define it in a second, but this makes the logic simpler, probably, hopefully. All right, that's done. Then we're going to do cipher 2. Cipher 2. And that's going to be encrypt 2. And what does this take? Anyone want to guess what would go in here? The key goes in here for sure. Key goes in here. And what else needs to go in here? Remember, this is the other XOR operation. So what else would go in here? Not len. Cipher 1. Right? Because we're taking block list 1, and we're XORing it with IV to get cipher 1. And then cipher 1 should go in here. And you XOR it with the key. You see that? So that's, what I just did in the little diagram that we saw a second ago. Plain text, initialization vector, XOR. That's that first cipher 1. Cipher 1 then goes into this square here, block cipher encryption, key goes in there, XOR, boom, cipher 2, done. Notice that ciphertext that comes out here now needs to become, for this iteration, its input. And what is this usually? And what was this in the first step? IV. Do you see that, guys? Does that make sense for everyone? All right, so then you guys should be able to tell me my next step in the code, right? So this code, think about it, this code does iteration 0, block 0. Then goes again. This is 1 now, block 1. So block 1, right? IV. But IV was a thing initially that we only use it once, right? So what do we need to do now? Instead of IV, what do we use?
Cipher 2.
Yes, cipher 2, right? Cipher 2. And so, very good. And the easiest way of doing that is what? IV equal cipher 2. You see that? Pretty straightforward. So this should be very clear. You know, we're not getting distracted by what goes on inside encrypt or whatever. We're just trying to get that little logic of how this should be done. And then, of course, we should record, you know, as we are creating our cipher, this is the thing that we want to send out. So you're going to say list of ciphers. And just to keep it simple, we're just going to keep track of it as a list. Then we can like append the list, send it out, or just, you know, pickle dump would just dump the whole thing, right? So it would make it super easy to load it back to a list later. That's the beauty of such a library. A library that also has a vulnerability, by the way, for those of you that like suppression. All right, so we've done a list of ciphers. Okay, so we got list of ciphers there. It's just empty. Now we're going to go in here. Okay, and we're going to say list of ciphers dot append. And we're just going to add cipher 2. Right, and that's literally the whole encrypt. We just have to drill down into the mechanics of this encrypt, which you guys already know how to do it with the caret symbol, but we're going to define those. I could have probably just created one encrypt instead of encrypt 1 and 2, but I'm trying to keep this super clear. But I leave it to you guys to make it more, more elegant, if you will. All right, so let's do list of ciphers, right? And that's what what this should return. Okay, so we've got that. So now we can just go ahead and define our 2 encrypt 1 and encrypt 2, which currently don't exist. You don't have to delete the hash function. It's not doing anything. So just leave it there for now, if you like. Okay, so let's do encrypt 1. Remember, that's the one for the initialization vector and the original plain text. So define encrypt 1. Okay. 1, 2, 3, 4, return, properly defined. But now this takes the plain block, comma, and it takes, technically this takes the IV, right? Not the key. You can use either one. It really won't matter. So I'll just use key here, but just be aware in this step, we are using the initialization vector or the previous block, etc. Okay, so similar idea. So I'm just keeping it consistent with the code, the way I did it last time. All right, so 1, 2, 3, 4. Okay, so what do we need? Basically, whatever we get, we're going to return a byte array. So let's just I'll do it like this. So I'll do res for now. Okay, I'm going to start with a list comprehension, right? List comprehension. So this is in Python where you put a for loop in one line of code, a one-liner, right? And then the result of that is a list. So it's super convenient. So let's do one of those. Comprehension. So I'm going to start with the for loop. So for I in range. Okay. And this is the plain block, basically. That's all it cares about, that block. So I'm going to say that I want the length of it, which is 8. You don't want to hard code it because then when you make it, let's say you upgrade to 32 and you're going to break your code. So len of plain block. So plain underscore block. There we go. That's it. All right. And so what do we need? So this is because we're going to iterate through the letters in plain block with an index, right? So we're going to basically take plain block, plain underscore block, and I got my letter. Do you guys see that? Got my letter. I'm going to XOR this with, remember, XOR operation in Python is the caret, like that. And then I'm going to XOR it with the key that I provide, which should also be of size 8. So this one is actually not a problem because that's already bytes, right? So the problem we have currently is that the letters here are not going to be interpreted. So we need to convert this into a numeric expression, and then the numeric expression, you'll be able to XOR it, basically. Remember that in Python, everything is kind of stored in the same way underneath, right? So it doesn't really matter like int or byte. It always saves like in the lower level space. All right, so all we need then is the function that we learned about for the substitution cipher, right? So if you remember, I gave you the substitution cipher. So we practiced that reading the ASCII table, so ORD and so on. So we're going to use the ORD function again. And this just converts our letters using that ASCII table basically into the numbers that we need. And hopefully that should be it. So we got our plain block letter by letter. We run it through the ORD that gives us a number, and then that number can be XORed with the key. And we have our first XOR operation. Does that make sense, guys? Now, the last thing you want to do is you want to convert this into a byte array. So that's why I kind of separated this. This is a little bit different from the code. So in the code, this is just one line. But I guess for clarity, I'm just going to specify here, this is typecasting. So I'm just going to do byte array, similar to the byte array that we use for the key, and just return basically res. Just like that. Okay. Any questions? Any question? So we completed that part. So if we go back, this code that I just wrote, just to get in the diagram format, means this and this have already been XORed, and you're like at this stage right here, okay? And now we're going to do the next step. So I need to take what comes out of here, which is another block. Remember the definition of block ciphers, n bits, map n bits to n bits, right? You know, that's what we just did. And so I'm going to take this one and XOR it with key, which is not IV in this case. Now it should be the key. And that produces the first ciphertext. And it should be secure because it doesn't have the insecurity of ECB that you should understand already. All right, so let's go back to the code then. So now we should be able to add a new line, a new function, sorry. I like to use these so the code looks cleaner. So this would be encrypt2. Encrypt2. Also, one thing that I guess stress, all these scripts are important because at the end of the semester, you'll have a practical exam, and I could encrypt something in any of these scripts, right, that you're seeing. Like I could just, for whatever reason, hide a secret key using this code. So you don't have to write code from scratch on the practical. You can use all the scripts that you have in class, but you need to be able to give it inputs and get outputs. That's what I'm saying. So definitely try to master these scripts. Okay. Don't think that you can just like forget. All right. So encrypt2, same idea. Let's look at the function over here. Encrypt2 takes what came out of here, cipher1, which we will have, and the actual key, not the IV. So remember now, this key is definitely, now that you know that you send keys securely using asymmetric encryption, this is what you would have to use RSA for, okay, to achieve authentication. So just to give you an idea of how the practical would work, I would probably have hidden a message in, I would give you the, instead of plain, I'd give you the cipher, and I would give you the key, but the problem is the key is encrypted with RSA. So then you have to, it's gonna be that scavenger hunt type of a thing where you need one piece, you need the key. Okay, I have the key, but the key is encrypted. So then, it's gonna be like that. All right. So anyway, so the key needs to be secure in this case. So let's go ahead and define encrypt2 at the colon. The parameters are going to be for encrypt2 plain block, although this technically should be a cipher block because this is now encrypted or XORed. So plain block, in this case, any name is fine. And you have the actual key. Okay. This is consistent with what is on GitHub. So 1, 2, 3, 4. And now I'm going to do the same. Return. I'm going to break this up into parts. I'm going to do res again, for result. Another list comprehension, Python list comprehension. In this case, what am I going to want to do? I want to, once again, grab each of those 8 elements right in the block. So I'm going to do for I in range. Okay, for I in range. And len of plain block. Len of plain. Like that. Okay, so same idea. You can see it's very similar. There's some subtleties, but it's very similar. The one difference is that this one does not have a letter that needs to be converted to a number, right? Like the plain text one. So that's why we needed to have. So in this case now, same idea. I'm iterating through the block. Oops. I'm gonna do space. Okay. And then here I'm gonna say plain block I, right? So I'm grabbing that first element, and what am I gonna do? I need to XOR it. There you go, with key in this case. Key. I guess a little mistake here. Let's get rid of that. All right, and that's it. So notice in this case, I didn't use the ORD basically, because not everything is numbers now. It's going to be, this is bytes and this is bytes, and I should be able to XOR. That's it. So should be done, right? Hopefully. So let's, I'm going to save it so I don't lose it. And then I'm going to go back to it. I'm going to scroll down. So we have defined the encrypt function, the encrypt message, sorry, which is this one. And notice it uses 2 functions, encrypt1 and encrypt2, for the 2 steps in the diagram. So now that I've done this, I should be able to run it. Let's see what happens. Okay, so let's go all the way down here, right? So this should give us a list. I'm going to print cipher list like that. Print cipher list. Let's run it. Control X, Y, enter. gave me an error. Type. Non-type object. Script message, cipher list, gen Q.
You don't have anything in your return for script two?
Did I not do that? Okay. Okay. Good. Yeah, good catch. Thank you. I was supposed to convert it to byte array also, right? Yeah, good observation. Perfect. All right. So I was missing some there. Thank you. Let's take a look. Encrypt 2 will take res, just like that, and we need to typecast it to byte array. And then, yeah, thank you. Okay. And now, should be correct. Just double check that function one last time. Yeah, we add it to the list. We return here. Okay. Let's try it. Let's hit clear. Okay. Thanks. All right. So this is your cipher. You've encrypted your message. You need to send it to your friend. How do you do that? Right. So that is a challenging. Some of you might be tempted to just gonna copy this and put it in an email. Don't do that. Actually, it's a really bad idea because, as I said, it's weird when you go from one program to the other, especially with characters like this, they get interpreted differently. So what we want to do is we want to save these things correctly. Okay. So we want to save it to a file or something like that. So there's a couple of options here. So let's see. And that's provided also in the code I gave you. We can do, reading and writing from files actually becomes important in this class just because of this problem. It becomes like a thing, like an expertise that you have to have just to be able to write these things correctly. So in the code I provided, if you look, there's an example of how to write with the open and then W and all that. So you can do that, or we can use, the pickle library. The pickle library is really nice, and I'll stress this again, in Python, because, let's say you guys know data structures, right? So you created a powerful data structure, complicated data structure. You wrote the code for it. When you run your program, that data structure is in memory, is in your RAM, right? And it's exactly the number of bytes that, let's say it's like 120 bytes or something. And that is like, however it is, when the code is running, Pickle can grab that from RAM and just dump it to a file, right? And then the beauty of that is when you need that again, you just grab that file, read it, and dump it back into memory exactly in the format of that data structure. So it saves you a ton of processing out and then processing back in. So it's super convenient. All right. So that's why, especially because I have bytes and things like that. And I actually think about what I have. I have a list of bytes and I don't want to mess with them. I literally want to save that list of bytes as a list of bytes. And then I want to read a list of bytes, and my life is so much better. Okay, so that's what we're going to try to do. So it should be pretty straightforward. It's similar to the example code I had given you before, but with the Pickle library. If you haven't already added Pickle, just make sure you do so here. It should be a built-in library of Python, so you don't need to install it. So we're going to go down here, and we'll use it several times this semester. All right, so now I'm going to just add a line here kind of for separation. Okay. So we're going to say file X equal open open that. We're gonna give it a name. So in this case, I'm gonna use single quotes. And I'm gonna call it pickle cipher list. Pickle cipher list. Okay. You can give it an extension if you want. It really shouldn't matter. I mean, .bin or something like that. I'll skip that. Comma, and then WB, right? So this is a write bytes, which is what you're writing. Okay. Then you can do from, this is going to be the handler to pickle. So from, this is just a name I made up. You can use other names. So from pickle cipher. Wait, hold on. I'm trying to write. Okay, so file X open. Yeah, I'm trying to. Okay, that's correct. Open pickle cipher list WB because I'm writing. So I just need to dump. So I'm gonna do pickle dot dump. Okay, and cipher list is what you are gonna send to the file cipher list. And you need to provide here the handler. So you need to say file X. Does that make sense? File X just tells it how to write it and to what. So you're going to write it to pickle cipher list. And then you need to tell it what to write, which will be cipher list, which is a list of bytes. Okay. So that's going to be. And then once you do pickle dump, you do file underscore X dot close. That's it. So that writes it. Okay, so you're done. Now, we want to also read it, right? Because, what you guys will do is one of you will create the message, write it, and then you send it via email, and then your classmate receives it, and then they need to read that file, right? So using pickle. So in that case, you're going to do, let's use file Y, and this one has a little bit different format. You're going to say open underscore. This is going to be the same file name, so it has to be pickle cipher list because it's what you just send via email. Cipher list, comma, and then this one it needs to be RB because you're reading bytes, not writing bytes. Okay, and then in this case now, you're going to say from I'm going to create this new thing. So this is the thing that's going to like read from the file and load it into memory. So a new variable that I'm creating, right? So from pickle, and that should be CKLE, cipher list, okay? And so we just assign to that from pickle cipher list, we invoke pickle dot load in this case instead of dump. And what do we read? File Y. It's a file Y, which is the event, the handler for the file connection. Make sense? And then of course, always close when you open something. So now I'm going to do file underscore Y close, just like that. All right, so if everything worked, I'm going to add another line just to kind of separate this out. If I did this correctly, I should be able to print from pickle cipher list, right? And super easy. You can email this file, whatever, and you're just taking a snapshot of memory and saving it. All right, so I should have the same thing twice. So let's try that. So Control X, Y, enter. So this thing, notice it's got the square brackets in front, commas, separating these things called byte arrays. So that's the list. So I'm going to do clear here, right? I'm going to run it. And there it is. So I have, this is the one initially, and this is the one that was written to file and then read from that. All right, pretty easy. So that's what you can, makes your life easier. That's what you can send to your classmate. And then the file should be this one. Oops. So this file here is the file. Okay, perfect. So that does encryption. We're done with that. So now all that's left is to decrypt and we should be good, right? I actually think one of our students a few semesters ago read one of the images into this code and it worked perfectly. So if you guys want to do that for fun, you obviously need to take the image, process it in a way, but that's what he did. So that was really nice our homework. All right, so now we're gonna do, we've got the file, so let's go back to the script. So ls nano, we were doing, so nano CBC. All right, so now what we want to do is decrypt. So we're going to decrypt off of after the pickles, right? Now, one thing I'll say, I'm sure this is obvious, but this is really two scripts, right? One script that runs for the sender and one script that runs for the person who receives. Because the person who receives doesn't have to encrypt and decrypt, right? They don't have to encrypt anything. They just have to decrypt. So, right? You guys see that? So just comment out the parts that you don't need. All right. The functions are fine. Just comment out in the main area. All right. So now should have enough time to wrap this up today, which is good. So let's do the decryption. So I'm going to call it PK decrypted. Oops. Let's do it lowercase. PK decrypted list. All right, let's call invoke a function, decrypt cipher. And what does it take? It should take from pickle cipher list. That's what you receive via email. And then what do you need? You also need to have the key, of course. Need to have the key. And you need to have the initialization vector. The initialization vector can just be a thing like part of the algorithm if you'd like. It doesn't, the security of it is not necessarily affected by it, but the key, of course, needs to be secret. The length of block may not be needed here since it's already padded, right? And the padding was like spaces or something. So it just depends how you want to do it. So now that this is, hopefully this is clear. Once we finish, we would need a print statement here just to see our original message. I'm not gonna like put it together or anything like that. I leave that to you guys. You want to clean it up more. You can always take a list and do a join, list join, and you'll join it as a string. So PK decrypted list. Okay, so now all we need to do is define decrypt cipher. So I'm going to go up here. Yeah, probably here somewhere. I'm going to add a new line. And I'm going to say, define, okay, that's the last part of it. And decrypt cipher here, we're going to have a couple of functions. So the idea is very similar, and this is what I was saying. This is a little bit harder. So just implement something, debug it a little bit, and think about the logic, right? So let's see. Define decrypt. Oh, I have two defines. Define decrypt cipher. We've already established that this takes the list of, here I can change the names, not a problem. List cipher, we got the key, and we've got the initialization vector, which needs to be provided. So you'll need to send that too. Key and initialization vector also need to be sent. So 1, 2, 3, 4. So now we want a list of decrypted blocks that will hold our decrypted message. List of decrypted blocks. Okay. All right. And then we're gonna iterate again. So for I in range, colon, len of list cipher. So let's say we have 23 or 27 blocks in there. So each block, we're going to iterate through it. So it's now so here's like the heart, the word, you know, the beef of the burger, right? The whatever, the central problem. 1, 2, 3, 4. How do we do this? Right? How do we, and let's use the idea of having two decrypt functions just to keep it simpler. So it should be the same idea, right? We need to, you know, two things, right? So let's just think. I'm going to say temp and plain. That makes sense. So temp and plain. Okay, we know that. We're going to have, just like before, decrypt 1 and 2. Notice before it was encrypt, this time is decrypt. Decrypt 2. Okay, so we have that. So initially we had plain and IV, and then we had the result of that cipher 1 and key. This is in reverse, right? So it's makes sense to think that here it would be key, and then here it should be IV. Do you guys see that? Maybe. Okay, then what else? So here then, what comes in first? Well, the message, right? The cipher. Cipher needs to come in here. So the first cipher is list cipher. I, right? So the first block, the first encrypted block comes in. Is it the first block from the beginning, from the end? How does that work? You know how we went that way, right? So are we going back this way? So we have to think about that. I'm not saying this is 100% right yet. That's why we're going to print it. And then in theory, then what would go here is temp, right? So temp. You guys understand? We're just going to align these. It's easier to spot any errors. Okay. And if that's correct, then we would add plain probably after this one. Make sure that's perfectly aligned. List of decrypted dot append. And what do we assign here? Plain, right? The first plain message. Okay. So once that's done, if that's correct, we just return 1, 2, 3, 4. return list of decrypted, right? Just like that. All right, so decrypted block. So I'm rushing here. List of decrypted. All right, good. So now maybe this is correct, maybe this is not. We'll see, right? But for now, this kind of makes sense. This is great because we're going to see it in plain text. So actually, we know what it should look like, so we can debug it a little bit better. We do need to define these decrypt functions, though. Okay, so I'm going to just add them here, which is basically the operation. I'm really just going to do one-liners for these. So I'm going to do define decrypt one. This takes a cipher, comma, key, colon, 1, 2, 3, 4, return byte array. Byte array. Okay. And this is going to be the similar idea of the list comprehension in Python. Let's see what happens. So it would be for I in range. For I in range. Len of cipher. Right? We're iterating through the elements. CI spaces. Okay. This should have square brackets, I think. Because of formatting, we may not need it, but let's see. All right, so now it takes key. So we have done this many times before. And that is XORed, which with cipher in this case. And that should also be it. Right? And that's bytes, so there's no need for ORD. In the next one, though, we need to change whatever that number is back to a string using the ASCII table. All right, so let's go ahead and define finally. So this, if we got everything right, we would be done after this next. Please look this one over in case I have like a parentheses missing or something. Define decrypt two. This one will take, let's just keep it consistent, cipher, whatever comes out of the first one, and probably the initialization vector, which we will need to move around a little. Yeah, so again, the logic we'll need to work on that. So 1, 2, 3, 4, return byte array. I'm gonna res, just easier for me to see this. And I'm gonna say return here. Byte array res. Okay, so I'm doing that just to clean it up a little. All right, so same idea, list comprehension. For I in range. And this is going to be len. Oh, no. It'll be len of cipher, right? Same idea. Okay. And here it's going to be key I store cipher I, right? But the result of this operation, that number, that set of numbers now needs to go into the reverse ASCII table. So now it's going to give me like, what was it? Like 79 was A, right? Something like that. So we need to, just like we did in the substitution cipher example, here we want to use CHR. And this reverses and gives us back the letters from the ASCII table. Make sense, guys? This is almost it, except I'm pretty sure there might be a little subtle issue going on, but in general, this should be the mechanics of it. Okay, so this is what I was saying. I don't exactly, like I need to see what the output is to kind of piece it together, but the function should match what we have on the bright space. Unless I missed something. So now let's run it. That's the key. And see if we get an error or if we might get an error. Yeah, so it's string object cannot be interpreted as integer. Which object is that? Yeah, so that decrypt 2 didn't like that. Okay. So we need to find that error. Let me try. I remove these square brackets from just decrypt 1. Okay. There's something it's not liking there. All right, so when you get this, you got to start debugging, right? That's the only solution. So let me add the square brackets again. Decrypt 1. Just add them in there. Okay, so what is, I need to know, so I'm going to need to know here. Address equal print res. I need to figure out where the error is. Return res, right? Do you guys see that? And then we need, what am I missing? Let's print cipher. Cipher. Print key. Print. All right, so let's just run it. Let's see if we can find it real quick. If not, just continue this next Thursday. So I get a byte array, another byte array, and this one. So that's 3. Two, even this one, 3, there's 3 prints. So it actually processed this, right? That's what that tells me. Yeah, that's the line. So they're there. They're all byte arrays. So where's the error then? I thought it was breaking here. Any thoughts, guys? Anything you're noticing? So it didn't break there. So then this must be returned correctly. So then decrypt 1 works just fine. So then it's in decrypt 2. Okay. Let's take a look at decrypt 2. All right, work on this, right? I know you have the exam on Tuesday, but also for fun, work on this, right? And then I'll finish this up next Thursday after the exam, but just keep in mind, we are going to start a new topic next Thursday, which is RSA. Okay, any questions? We're almost there. But yeah, all right, we can stop here and don't forget to submit your assignments for tonight if you have any. And then study for the exam, and then we'll finish this up. Have a good so I'll stop the video right now.